this is a coin. I can flip it, and I could get heads or tails, and we're going to use this to do a one-dimensional random walk. I'm going to model it in Python. Really, the whole point of this is to use my new histogram tool to make an animated histogram. That's what I'm going to do. So the random walk in 1D, let's imagine that I take this coin and then I flip it. And I catch it, and if it's heads, I move one step this way. If it's tails, I move one step this way. And I just keep doing that again and again and again. So that's not too difficult to model in Web VPython. We're going to make a visual of that first, and then we're going to do a whole bunch of other stuff. And see, look, I even wrote 1D walk right there. 1D random walk. Okay, so let's jump over to Web VPython. Let's just build some code, and let's just get going from there. So here we are, Web VPython. I'm going to go ahead and make a ball that I'm going to move back and forth. So the ball is going to be a sphere. I'm going to put it at the origin. This is super easy. I need a radius, let's say 0.1. Let's give it a color. It doesn't really matter color. It's color.yellow. And let's give it a make trail equals true. And there's some really good analysis that you could do with random walks, but I'm not going to do that. I'm really focusing on modeling it and making an animated histogram. That's all I care about. Okay. So, of course, when you make a ball, you should run it, just make sure it works. Okay, so there it is. Good. Now, I'm going to make a loop. How many steps do I want? Let's just try 10. So I'm going to do this. I like to do lowercase n is my counter, capital N is my number. So I'm going to set it to 10. And then I can say, oh, I need one more thing. Step size, I'm going to call that S. S is 1. One step. While n is less than n, I want to do the following. Now I'm going to animate this. So since I'm going to animate it, I need a rate statement. Let's just put rate of 5. So this says don't do more than 5 steps, 5 loops per second. Okay, that's the animation rate. So the first thing I'm going to do is to create a random number. Now in Web VPython, there's only one random number you could do. I'm going to call this RT for temporary random number, and it's random parentheses. This returns a value between 0 and 1. How do we change that into heads or tails? Well, I'm just going to say if that number is less than 0.5, move in the positive direction. If it's greater than 0.5 or equal, don't really care. Move in the other direction. Now, yeah, that's not fair, right? I can't include 0.5 because it should be both places. I don't really care. It doesn't matter. It really doesn't matter. You're probably never going to get 0.5 exactly, so just don't worry about it. So let's just do this. If RT is less than 0.5, then I'm going to move the ball to the right. So ball.pos is ball.pos plus vector. It is a vector here, right? We're doing 1D, but I'm showing it in 3D. So you have to have this as a vector. Vector S00. That's 1 unit in the x direction. Now, I don't need to do anything else. I can just say else, right? Because if it's not less than 0.5, I'm going to move it. It's not like I'm not going to move. So else, the ball.pos is ball.pos plus vector minus S00. Now here's the part that I always forget. I need to increase my counter. N is n plus 1. Let's just run it. Kind of cool, right? Let's run it again. Something different is going to happen. And so, you can do a bunch of things like what's the average position? It should end up on average, back at 0. That's the most likely position to end up. But it can end up anywhere, and the distance from the origin that it ends up has some dependency on the number of steps. But again, I'm not going to do that. I want to make a histogram of the final step location. That's what I want to do. I want to say, where does it end up after 10 steps, after 100 steps, and then redo that a whole bunch of times and get a distribution. That's the whole point, and then we're going to animate that. Okay, so if we're going to do that, we don't actually need this ball. I don't really need to do that, right? I don't really care about that. And so up here, I'm just going to call this xt for temporary x. And I don't really care about moving it, so let's just change this to xt equals xt plus s, and this is xt equals xt minus s. So it's just a one-dimensional problem now. But other than that, everything's the same. You just don't see it. So let's print. This is print the final position, xt, and let's do that a couple times. Print xt, print xt. Now, I still have that rate statement in there, so let's get rid of that. Because if I'm not going to watch it, no one cares, right, how fast it goes. So this, we should get different values. 222, strange. 444. Oh, you know what I didn't do? Okay, so every time I redo this, I need to. Oh, it's printing the same thing because I didn't change it. That's right. Okay, okay, that was my fault. Okay. But what I want to do is to run it, let's say, 100 times, and then repeat that run 100 times. And so find that final position. So with that, what I'm going to do is to make a function where I give it how many times I want to do the random number steps, the one-dimensional steps, and it returns a value of how far did you get. Okay, so let's make this a function. I'm going to go right here, def, I'm going to call it 1D, and I'm going to give it nt. So nt is the number of steps. And so all this stuff I need to put in my function. So I'm going to start off at x equals 0. I'm going to start off with n equals 0. And then I'm going to go to nt, that's my number. That's fine, that's fine, that's fine, that's fine. And then once I get done, I'm going to return xt, right? Where did it end up? So let's print that several times. Print 1D, let's say 100. And let's just do that 3 times to see if we get 3 different values. Now let's run it. Okay, so it seems like it's working. It's hard to tell, right? They're all over the place. That's what I want. Okay, so now what I want to do is to run this a whole bunch of times. Let's just say I do 100 runs of 100 steps, and I want to plot where they end up. That's the fun part, right? Now, to do that, I'm going to have to make a histogram. And if you have my video on histograms, you know that we need to do some work. Okay, so I have that function 1D, that's gonna do the whole thing. This n up here, I'm gonna change this to 100. So that n is gonna be my counter for the number of loops. And let's call this, let's just change these to nt right here. So I don't reuse the same thing. And that's just me being paranoid. Okay, I don't like to reuse the same numbers. Numbers are conserved, letters are conserved. Not really, but that's fine. Okay, so if I want to make a histogram, I need to do a couple things. I'm going to plot my x bin values versus my count on the vertical axis. So I need to pick how am I going to space out those bins. So let's say x1 is going to be my starting value at -50, right? Because it could end up 50 paces away. We can change it later. And then x max is going to be equal to 50. That's the span of my histogram. And then I need a bin size. So let's call that dx is 4, right? I'm going to go 4, 4, 4. So what I'm going to do is to run my thing, and if it's in that width of 4 units, then I'm going to count that one, and then so forth. You'll see what it works out in just a second. So I need to make 2 lists. I need to make a list for my bins, and I need to make a list for my counts. So let's call that x bin as an empty list. This is Web VPython. We don't have arrays, so we're going to have to do this the more complicated way. And let's call this fs for my counts, fs. So they're both empties. Now what I'm going to do is make a loop while x, let's just call this x. While x is less than x max, I'm going to add things to my list. So x bin is x bin plus x. And I'm going to add fs, I'm going to add a number to that of 0. Because that's my count, right? So I'm going to set all my counts to 0. And then when I can go in through later and I can count things, I can add stuff to that. Now I need to move my x equals x plus dx. And then let's just print out my x bins. Let's see what they look like. Print x bin, just a test. Just a test. I feel like my thing's too small, but that's fine. Okay, so it goes from negative 50 to 46, doesn't go all the way to 50. That's fine. Those in ones aren't going to be really important anyway, but it looks like it's working. So we have our two lists. Okay. Now what we can do is to go through and run our thing 100 times for 100 steps. So I'm going to say while n less than 100. So n is my new counter, right? That's my counter of how many times I'm going to do this. Oh, I could say n. I can just say n. I didn't know if I ever used that. And I'm going to make that a little bit bigger. Is that too big? I like it like that. Okay. So what I want to do is to run 100 steps. And I'm going to call this number xrand. I don't even know why I'm calling it xfinal. Yeah, let's call it that. And it's going to be 1d of the number of steps, which I'm going to call, let's call this n steps, equals 100. They're both 100. We can change them. I like to put them at the top so we can change them. N steps. Now what I want to do, did I call it steps or step? Steps. See, I caught my error before it even happened. In steps. Now what I want to do is to go through my x value bins and see where does this number lie. And I'm going to count that one. That's the same thing I did in my previous histogram. So I'm going to say for I in range length of x bin minus 1. So remember that I have a whole bunch of bins and numbers, but the bins are in between the numbers. So I'm going to have one fewer bin than I have number. And I have to do this, otherwise things are going to get out of range. And I'll show you why. Now I can just say if x final is greater than x bin I. So x bin I is the ith element in the x bin. Remember, those are numbers, negative 50, negative 46, negative 42, and so forth. And x final is less than x bin I plus 1. All right, so I want to make sure it's in between those two numbers. If it's not in between those two numbers, I don't want to add it to that thing. And that's, again, if I went to a range of x, the length of x bin, I would get to that last x bin, and there's no one after that, so I couldn't do this calculation. So once I find that, I'm going to add one to the counter of f that's the same part for x bin. So fi equals fi. I'm going to count plus 1. That's it. Okay. Now I just need to add 1 to my n. N equals n plus, n plus 1. And that should be it. Yeah. That's it. Okay. Now I'm done. I have my list. Let's just print fi. Print f. Oh, that's called fs. I'm sorry, fs. fs. So let's print fs. Let's just see if it works, and then if it's not working, I'm not going to worry about the histogram yet. So let's just run this, and then there's my count. That actually looks pretty good, right? Because I have zeros in the ends, which are very rare events, and I have more in the middle, so that's good. So to plot this, I have my two lists. I just have to plot them. So let's plot them by saying, oh, I need to make a graph. G1 equals graph. Title equals 100 1D steps. That's good. X title is called X final. Y title is, you can't see that. Not that it really matters. Y title is, let's say, count. And then let's put width 400, height 200. Now I need that's my axes. So the graph is a function called a GV bars. So GV bars is a vertical bar graph. I want the bars up and down. So one of the things is how width are the bars. I'm going to put the width at dx, and then I'm going to have a color of color dot blue. Okay, so now I can go through and plot that for I in range length of x bin. I'm going to plot them all, even though that last F, there's nothing there because I didn't have anything associated with that. That's fine. F1.plot. I'm going to plot my horizontal variable, which is xbin I, and then my vertical variable, which is fsi. And that should do it. I haven't saved this in a while. Save. Run. It worked. Okay, let's run it again. So you see this normal distribution, but it's not perfect. I only did it 100 times. So that's that. I can rerun it all the time. That's pretty cool. But what I want to do now is to let the graph build up over time as things are going on. That's going to be cool. That's going to be better. So let's make this an animated histogram. So down here, when I'm making the graph, instead of, I want to plot the graph every loop. Every time I have a new end, I'm going to make a new plot. Okay. So the first thing I need to do up here is to add a rate statement back in. Let's say a rate of 10. That's going to take 10 seconds to run if there's 100. So let's say 20. 5 seconds. Okay. So, and in order to do an animated graph, you have to use this thing called f1.data. I'm going to make a temporary list of values to plot, and I'm going to call that f1data. And it's an empty list. At the beginning of the loop, I'm going to throw it away. I'm going to make it empty. Now down here, once I have my data, I'm going to populate my list. So I can do that right here, the same thing I did up here. Let's just control, paste that right there. And instead of plotting it, I'm going to just add to a data. So I'm going to say f1 data equals this data point. Oops, like that. So now at the end of that loop, once I've made my data, I can plot it, and we can do that with f1.data equals f1 data. And this f1 data, you can call it whatever you want. Okay. So instead of plotting one point at a time, which is what it normally would do, it's just going to add them all to the list and then plot it. And then when you go back to the beginning of the list, it clears it out, so plot it again, and it looks like it's animated. Okay. Let's see if that indeed works. But now I can't put that right there. I have to put this up here. Yeah, you can't plot things before they exist. Okay, I think this will work. And it didn't. So what did I do wrong? F1 data, F1.data, F1 data, got that. F1.data equals fdata. Why isn't it plotting? GV bars. I got that already. That was working. Fdata. For I in range length of xbin. F1 data. Oh, I know what I did. Okay. So this is F1 data plus. I have to add that to my list, right? I can't just set my list equal to one thing. That's why it didn't work. Is that pretty cool? Okay, maybe it should go a little bit faster. Let's do 50. And then we'll do one more thing. That looks pretty cool. I'm pretty happy with that. Okay, let's do even more. Let's do n is equal to 500. And then let's do this at 100. Now, I'm going to let it run, okay? And then, one of the things that it does is it's auto-scaling that graph. And you'll notice that, the middle point, what's the maximum middle point going to be? It could be 500, right? It's not going to be 500. But let's just see how far it gets. It got to 50, okay? Let's just set the maximum y value to, let's say, 60. And that way, it won't have to rescale, and it'll just look cooler, but it doesn't have to be that way. Okay, so up here, I'm going to say, y max equals, let's say, 65. Yeah, that's what I want. That's pretty cool. That's what I wanted. I only wanted to do this video just for that. And we just like to watch it. I like to watch it. Okay, like I said, there's other mathematical tests you could do. You could see that this is a normal distribution. You could find the average. You could find the standard deviation. You could do it in 2 dimensions. You could do it in 3 dimensions. You could do it in 4 dimensions. You could plot the average distance as a function of the number of steps. That's a fun one. And you can find pi from that. If you want me to do that, I can do that. I've done that before in a blog post. But if you want me to do it as a video, I can do that. But that's that. This code is down below. One-dimensional random walks. Hope you had a fun time. I had a good time too. I'll talk to you guys later.